In continuation of quantum mechanics, the first lecture is wave function. The wave function is represented by the mathematically symbol psi or phi. The wave function psi as such has no physical significance, but the square of its magnitude, that is psi square, magnitude of psi square for a particular position and time, represent the probability of finding the particle at that time. Since magnitude of psi square is proportional to the probability p, probability is represented by capital P of finding a particle. The integral of psi square, magnitude of psi square over some space, must give a finite value, that is limit a tends to b. लोअर लिमिट हो गई a एंड अपर लिमिट हो गई b. तो मैग्नीट्यूड ऑफ साई स्क्वायर dv मीन्स वॉल्यूम इज इक्वल टू a means finite value, say capital N. But if minus infinity limit minus infinity to infinity, then magnitude of psi square dv is equal to 0. The particle cannot exist. If the particle at any position is present in a volume element dv, then minus infinity to infinity psi square is dv is equal to 1, or minus infinity to infinity p dv is equal to 1. If conjugate of psi square is the complex conjugate of psi, then magnitude of psi square dv is represented by psi multiplied by conjugate of psi dv is equal to n. Here psi upon under root n is known as normalized wave function, and the coefficient of psi that normalization it, that is 1 upon under root n, is known as normalization constant. Next topic, Schrodinger wave equation. Two types of Schrodinger equation. First, time dependent Schrodinger equation. The wave function psi of a freely moving particle along x direction may be given as psi is equal to a e minus iota omega t minus kx. A means constant, omega is equal to 2 pi nu, k is the wave constant 2 pi upon lambda. We know that omega equal to 2 pi nu and k is equal to 2 pi upon lambda. इसको पुट करिएगा इन इक्वेशन नंबर 1. देन वी गेट इक्वेशन नंबर 2, psi is equal to a e minus 2 pi iota nu t minus x upon lambda. We know that energy of photon is represented by E is equal to h nu. h को आप लिख सकते हैं h क्रॉस की फॉर्म में, तो 2 pi h क्रॉस nu. We know that according to de Broglie wavelength lambda is equal to h upon p. उसी को भी आप कन्वर्ट कर सकते हैं 2 pi h क्रॉस अपॉन p, वेयर p इज द मोमेंटम ऑफ द पार्टिकल. तो सारी वैल्यू आप पुट करिएगा इन इक्वेशन नंबर 2 में. देन साई इज इक्वल टू a e की पावर माइनस आयोटा अपॉन h क्रॉस e t माइनस पी एक्स, e t माइनस पी एक्स, इक्वेशन नंबर 3. देन डिफ्रेंशिएटिंग इक्वेशन नंबर 3 ट्वाइस विथ रेस्पेक्ट टू x. तो d2 फर्स्ट टाइम डी साई अपॉन डी एक्स, अगेन डिफ्रेंशिएट करेंगे तो डी स्क्वायर साई अपॉन डी एक्स डेल्टा एक्स स्क्वायर इज इक्वल टू माइनस पी स्क्वायर एच क्रॉस स्क्वायर साई. देन वी गेट इक्वेशन नंबर 4 एंड also differentiating equation number 3 once with respect to t, then we get delta psi upon delta t is equal to minus iota upon h cross e psi is e psi, equation number 5. Now for a particle total energy is the sum of kinetic energy and potential energy. So E is equal to t plus v, p square upon 2m plus v, multiply by psi in both sides. E psi is equal to p square upon 2m psi plus v psi, equation number 6. Using equation number 4 and 5 in equation number 6. using equation number 4 and 5, and we get iota h cross delta psi upon delta t is equal to minus h cross square upon 2m del square psi upon delta x square plus v psi. It is known as the time dependent Schrodinger equation. टाइम का फंक्शन है डेल्टा साई अपॉन डेल्टा टी, देन वी नो डेट this is the equation of time dependent Schrodinger equation, where